Alright, I've clicked the button. Please tell me that you're here. Let's do that. Begin. And if there are no questions, let's get started with clones, messages, and Pong. Oh my. So we're going to do some cool stuff in Scratch today. Today is a programming day. So please go to scratch.mit.edu and mentally prepare yourself. We have a new programming assignment out today too, so don't let me forget about that. So yeah, we're ready. We're here in Scratch. Let us begin. So I guess the first thing that I would like to teach you is this concept called clones. That will help you in your next programming assignment, I think. You are allowed to clone a sprite and make a million Scratch cats, for example. And they can all do their own little Scratch cat thing. Okay? That's pretty cool. I think what I would like to do is... Ooh, it looks like when I updated everything, I think my computer updated by itself. So that's unfortunate. Hopefully everything still works. So let's make 50 stars. We're going to make a star field. So it's going to look like we're in outer space and like we're moving around and all the stars are bouncing along. Let's do that. So let's make a star field by making 50 stars appear in random spots with random sizes and directions. And then they'll bounce around forever. Okay, so a lot of stuff going on there, but let's break it down and make a program that looks really cool. All right, so definitely for Backtrack, there better be a space backdrop. This one is a bunch of stars. Cool. We can start here. And then, instead of the Scratch Cat, I guess the Scratch Cat can hang around, but we need some stars, like a star sprite. And we have one right here. So here is one single star, okay? And the goal is, we would like to clone this star. How many times? 50 times. And have them all appear in random spots. Okay, that is the goal. And with also random sizes, like some can be giant, some can be tiny, like that. And also, we don't want them to be like slightly turned to the right, like that one is every time we clone it. We want it to like look like a star, right? In random direction. So whatever we're interested in, we want to make that happen too. Okay, so that's the game. And the Scratch Cat can just be floating around in space, observing all this cool stuff, I guess. So I have one star. When I start the program, I would like to clone that star 50 times. Okay? So there is a block that clones something. Let me find it. Dun, dun. There it is in control. There is a block called Create Clone of Myself, which is nice. So I click it. Now there are 2 stars. If I click it again, now there are 3 stars. Yay. And I don't know how to delete them all. Just go away, please. Go away, please. Something like that. Whee. There we go. I just got to click the green flag again for them to all go away. So when the green flag gets clicked, I don't want to create one clone of myself. I would like to create 50 clones of myself. So what block can I use to do that? I want to run this same block several times. I would like to loop. I would like to repeat. So, repeat 50 times, create a clone of myself. That's not too bad. Yay. And so when I run this program, I'm going to make 50 stars. Go. Dun, dun, dun. And it did it, and we saw nothing. Nothing happened. But there really are 50 stars. They're just all on top of each other. See that? So that's no fun. We would like those stars to go to random spots, right? That would be useful to us. So let's make that happen. We want those stars to, when they begin their life as clones, to move to a random position, right? And there is actually a block that handles just that. When each clone begins its life, there is this. When I start as clone, do stuff. Okay? So the original star kind of runs with this program, makes 50 clones of itself. And then all the clones, they'll have a program just for them. When they start as a clone, please do something. Isn't that cool? So when I start as clone, each star should go to a random position. Does that make sense? Now, when I make my 50 clones, they're all going to be in random spots. Okay? Here's the original clone that creates all the others. Now, we make 50 more, and there they are, in random positions. Isn't that neat? And then you still have that original one just hanging around there, so technically there's 51 stars. Maybe after it has done its job, it doesn't need to appear anymore, so we can hide it. So we want exactly 50 stars, maybe. So once you've done your job, you can go away, or something like that. Show at the beginning. There it goes. And then at the very end, it goes away. You can do this in different ways, but that's one. So go to random positions, one thing. Then, what else do we want? Random sizes. So let's also have a random size for each clone as it begins its life. So where's that? That's looks most likely, right? And then we have set size to something, right? Set size to 100%. Maybe we would like a random size between maybe 50% and 200%. That seems like a good range. So I can go to operators and pick a random percentage, right, between like 50 and 200. And now some stars will be giant, some stars will be tiny. Whee, look at that. Isn't that fun? So maybe those are too big. I don't know. Maybe it should be like 25 and 100. Maybe 100 is big enough. But you can play around with this. 25 and 125. I don't know. Does that look good enough? But now we have 50 random stars, right? 50 clones of a star that each begin their life in a random spot, and their size is also random. All right. What else do I want to do? I want to give them a random direction, because right now they're all just kind of leaning slightly to the left. Yeah, you see that? So let's fix that too. So that's in looks again, I'm sure. That is, or maybe motion actually. What's the best one here? Point in direction. Yeah, so this is like an angle. Point in direction, some angle between, well, what angles are there? A star is symmetric, so you don't have to go every possible angle between 0 and 360, but that still works, so let's do that. So pick a random angle between 0 and 360 and rotate yourself that way, please, Mr. Star Clone. So now they're kind of just doing their own thing. Okay, I've got 50 random stars of random sizes with random directions that they are pointing in. Okay? Any questions about this code so far? Is that good enough? Make enough sense? All right. The last thing that I want them to do is bounce around, at least for now, because we want to pretend like we're moving through space, like we got a warp drive going on, and we're moving through space. So let's have those stars bounce around. And so I've given them random directions. Let's let them continue in that direction, right? Move 10 steps in your current direction. And eventually you're going to hit like the wall, so maybe they can bounce off the wall if they're on the edge. So I want to repeatedly do all this, right? Repeatedly move a little bit and bounce off. So that screams forever loop. Okay? So repeatedly move in your current direction, star clone, and bounce off the edge if you hit the edge, because I don't want to have you float off into nowhere and never see you again. So when I create, like when I start this program now, again, 50 clones get made, and this is the program that each clone runs. Go to a random position, set a random size, point in a random direction, and then forever move in your current random direction and bounce off the edge if you ever get to one. Okay? So look at them go. That's pretty cool. So that's the start. The last thing that I want to do is transparency. That's the last thing that I would like to play with this. because maybe like the bigger stars are closer to us and the smaller stars are farther away, and you have that like atmosphere. I guess there's no atmosphere in space, but they should be more transparent because they're farther away, right? So let's make that happen. Let's make the smaller stars more transparent. That is, transparency is controlled using this thing called the ghost effect. Whatever that is, change color effect. Let's show the star. If I change its ghost effect by 25, that makes it 25 transparent, I guess. Okay. And I guess I need to make it negative 25 to get it back to normal. So I would like some number to put here, right? Change ghost effect by something, having to do with my current size. Does that make sense? Can I get that as a variable, actually? Do I have my size? Yeah, there's my size. Cool. So I want to like set the ghost effect to something involving size, because the bigger, the smaller the size, the bigger the ghost effect I want. Okay? Something like that. So I need some kind of formula in terms of size that will make a big number when the size is small. Okay? Any thoughts about that? I think ghost effect goes anywhere between 100 and 0. Like 100 is see-through, and yeah, and 0 is just perfectly opaque. So I think it's subtraction, right? So if it's, what am I letting the size go up to? I'm letting the size go up to 125. Maybe that's too big. I don't know. I might have to do some division around this, but something like, I don't know, 100 minus size or something. Because if I subtract the size and it's small, that's going to make a large ghost effect, right? I think that larger means more transparency. And then if the size is huge, it's going to try and change the ghost effect by not so much, so it won't be as transparent. We see how that's going to work? I think that's what we would like, but the whole point of programming is that we get to try it out, so let's see if it works. Yeah, it looks like the bigger stars are less transparent, so that seems good. And you can play around with this, of course. Maybe you never want the ghost effect to get perfectly transparent. You always want to see the stars, no matter what. Let's see. Then you can like cap it somehow, like make it 75 or something. That might help. But yeah, it's just a bunch of magic numbers that you can play around with. Okay, so this is my fancy little star field program. We've made 50 clones of an individual star. We have given them life, transported them to a random position, given them a random size, given them a random direction, and had their transparency be affected by their size, which is nice. I can get my size because there's a size variable. It's always set to the current size. That's awesome. And then forever, we have those stars bounce around. Move in your current random direction, and if you hit the wall, bounce off. Okay? Any questions about this code? Kind of neat. You get to make clones of things. So I'll save this before I forget so that I can give it to you later. All right, so that's my first program that I have for you. The next program that I have for you is I would like to teach you a new kind of way to have sprites talk to each other. I like to recreate that ghost example, do you believe in ghosts example, using something called message passing, okay? And so here is the idea of a powerful programming language concept called message passing. We have, here's the metaphor. We have a sender, and we have a bunch of listeners, we say. Okay? So the sender is the sprite that is sending the message. It's like, I have something to say. Please, ghosts, show yourself. Something like that. That could be the message. So here's the message you want to send. It's got a little stamp and all that. And then, essentially, a message passing program just has the sender with the megaphone yelling out to whoever wants to listen for that message. The message for this program is going to be, ghosts, show yourself, or ghosts, hide yourself. Well, they'll have two different options to listen for, okay? And so any sprite who cares about that message will have their ears ready to go, listening for whatever message that any sender might send to them, okay? Maybe this one's going to listen to the ghost show yourself message, and this one's going to only listen to the ghost hide yourself message, okay? There can be as many as you need, but that's the real life metaphor, message passing, where like we have a sprite that is pretending to talk to other sprites, okay? So you got that concept of sender and listeners. And let me show you this working. All right, yes, I already saved it, so we're good to restart. What I would like to do is, again, start the program. Well, let's make it scary again. We had the woods, right? The woods with, what were our ghosts? There was a real ghost, right? And I think there was a skeleton. Oops. And a bat. So here are my scary ghosts. And let's try and recreate that original program. So it's something like, at the very beginning, all the ghosts hide themselves, and then we ask the user, do you believe in ghosts, right? And wait, and then we use the answer variable to do stuff based on that. Okay, something like, if your answer was yes, then we should show the ghosts. And if the answer was anything but yes, because that else covers everything other than that, right? Then we want to hide them or keep them hidden, really, because they start out hidden, right? So that should be the game. Let's use the proper operator and get this all, this boilerplate working here. So if the answer was like yes, then we'll show the ghosts. Otherwise, we'll keep them hidden. Maybe I don't even need the else case. Who cares? But that's like the idea of the code. It's a bit empty right now, but it can be filled with the proper things, right? So that's where we started, and now everything else changes, okay? We have message passing that I want to talk about now. So where is that? Dun, dun, dun. Sensing. Is it in control? Broadcast. There it is. Events. A message pass, or a message is an event. Okay. So here are all the different messages. There's a message one message. Let's make a new message. Let's say show ghosts. That can be a message. And then let's make another message. Let's call it hide ghosts. Can I rename message one? Because that would be extra helpful. Apparently not. Whatever. All right. Make a new message called hide ghosts. And the idea is the Scratch Cat, who is controlling the program right now, this is his program right here, he's going to shout out, like secretly, right, to the ghosts. He's going to pass a message to them. He's going to yell, show yourself or hide yourself, and then the ghosts are going to be listening for that message. That's a really powerful concept. It's very similar to what might happen in real life, and so it makes programs easier to write. Does that make sense? So I think you can kind of understand what needs to happen here. If the answer is yes, you do believe in ghosts, then broadcast, shout out the message to the ghosts, whoever wants to listen. It'll just be the ghosts, though. Broadcast the show ghosts message. Okay? Otherwise, broadcast the hide ghosts message. And then it's our job to have the ghosts listen to this and like do stuff with it. But that's kind of the game. It's a lot easier to think about. And maybe at the very beginning of the program, you got to make sure to whisper to the ghosts, please hide yourself to begin with. Yeah? So does that idea make sense, the way the program is set up right now? It's a bit simpler than last time, especially for the ghosts, because we were doing weird stuff with variables and having them listen to that variable in a forever loop. It was a bit ugly. This is a much cleaner way. All right, so yeah, again, the concept is we have the Scratch Cat, who is the sender. This is the Scratch Cat. And then all the listeners are the ghost sprites. They're listening for those two different messages, those two different kinds of messages that they care about. We got our skeleton, we have our ghost and our bat. Okay, they're listening for that message, and they're going to do stuff based on the message that they receive. So no longer do the ghost, the skeleton, and the bat need to start their program when the green flag is clicked. They don't need to wake up when the green flag gets clicked. They need to wake up and do stuff when they receive a message. Okay? So here is how the program will be structured now. So this is the ghost program that I'm on right now. So when the ghost receives the show ghosts message, do something. When the ghost receives the hide ghosts message, do something else. And there's only one block to put in each of these, right? It's so much cleaner than that forever loop. So it was looks. That's where that is, right? So when I receive show ghosts, I am a ghost. That is my name, in fact. I will show myself. When I receive the hide ghosts message, well, I better hide myself. All I need is 2 blocks. I hope you see how cool that is. So, yeah, again, concept of a sender. There can be multiple senders. They all know about the same message that they want to send. But right now, it's just the Scratch Cat who's like the conductor of all of this. And then the listeners, the ones that want to do stuff based on that message, if they hear it, are those ghost sprites. So each of those ghosts is going to get this same program, okay? When I receive the message show ghosts, show myself. Boop. You can just drag it into them. When I receive the hide ghosts message, I better hide myself. Let's make this pretty. Did you not get the show ghosts, Mr. Skeleton? Okay. What about now? There you go. Is that better? What about the bat? Did it work for you? Of course not. When you receive show ghosts. There you go. Oh, okay. Never mind. So now each of them have the same program. They have the same response to each message, okay? And so now when I run it, it should just work. It should just work. So click the green flag, bam. The first thing that happened, right, was we broadcast the hide ghost message, and each ghost is listening for that, and they know to hide themselves. Cool. And then we ask, do you believe in ghosts? And wait, that's what we're on right now. So do you believe in ghosts? We can say no, right? Something other than yes, because that'll hit the else block, the else part of the if-then-else block. And then again, we'll broadcast hide ghosts, but they're already hidden, so it's not a big deal. So technically, I didn't need the else block. I could have just used an if-then block, also valid, because I hide them initially. It's all up to you. And if I rerun the program, do you believe in ghosts? And the answer is yes. If that is true, and it will be true because I'm typing yes, we're going to broadcast that show ghosts message. And all the ghosts will wake up because they're listening for that too, and they know to show themselves. Isn't that cool? So much simpler than before, but it took a new concept. It's called message passing. Any questions about that? That's going to be another feature of a future programming assignment, if not this next one. I think it's your next one. I can't quite remember though. Okay. Are we happy with this? So let me save it. And again, I want to give you some time to play around with this. Maybe make a new message, do something cool. I'll give you like 5 minutes. Recreate my example if you haven't made it already, or I'll give it to you. And make them all do something cool. Maybe make a new message. Make like give them a say boo message so that they do it only when they're asked to by the Scratch Cat or something. Have them talk to each other. Do cool stuff. So let me give you some time to play around with this because I think that's a great way to learn. And if you want the code, the standard way of giving that to you appears to be Discord, so let me give that to you in Discord. If you feel like logging in. Good old Discord. Takes a minute to start. let me at least have the file ready, I guess. There it goes. Downloads folder, it was the second one. Go. Go. Alright, now you have it, if you needed it. So yeah, do something cool, take like 5 minutes, show your neighbors, and ask me if you have any questions, and then we'll come back and do Pong. I'll set a timer. Yeah, maybe recreate what you did last time. Something very wrong with this. If only there were speakers in each computer, then you could use sounds. Don't mind me. If you wrote an extra cool program, take a screenshot and put it on Discord, maybe. And I can show it off to the world. Let's do that better. I'll do this later. Oh yeah. Sure. Having fun with this, but I do also want to show you Pong, if that's okay. All right. So I think I can get out of this because it's just using a lot of memory. So yeah, ghosts, message passing. Hopefully that was fun. The very last thing that I want to show you before I release your next programming assignment is Pong. Okay? I want to teach you how to make the Pong game because that's like difficult, right? That's complicated. It's cool. I think we can all get behind this idea, right? So remember what Pong is, right? It's just let's make single player Pong. So you're playing against yourself. You're like hitting it against the wall. So Pong is made up of a paddle. Let's put the paddle on the left. And then we need a ball that bounces around, right? And then it's supposed to bounce off the paddle, boop, and then bounce off all the walls, if it's a single player Pong at least. And then the goal is, like, it'll keep doing all this until, like, you're tired of playing and you stop the game, or the ball gets, like, I don't know, down over here and you lose, right? If it hits the wall where the paddle is, then you've lost the game. So that's That's kind of how Pong works if we forgot or we never knew. So let's make that happen. Let's make a Pong game. So I definitely saved this already because I gave it to you. So let's make the game Pong. I guess we have to say goodbye to the Scratch Cat for once. We'll delete him. Sorry. And now we need a ball and a paddle. So here's a ball. That's nice. We need a paddle. That is already given to us, which is quite nice. I'd like it to be in a different direction, though, so let's set its direction to like 0. There we go. And I'd like a bigger paddle, so maybe like 150, 200 even. No, 150 is fine. So this is like our paddle, this is like our ball, and it's going to bounce off. Whee! Just like that. And then we want to make sure that the paddle can move up and down. Yeah. And that's very similar to the platforming stuff that I was talking about before, right? We can make the paddle move up and down with just an arrow key. But this time, I would rather have the paddle follow the mouse pointer, because that's cool too. Whenever I move my mouse, the paddle should follow my mouse. Won't that be nice? That's how I want that to work. So let's get that working first. Let's make the paddle follow the mouse pointer. Let me show you how to do that. So there's this go-to mouse pointer, which is almost what we want, right? If I did that, when the program starts, I go to mouse pointer always, like I want to repeatedly do that as the mouse pointer moves, so I want to do it forever. If I did this, that's almost there, but now the paddle's allowed to go way over here, way over here. It follows the mouse pointer though, that's pretty nice. But I only want it to be able to go up and down based on the mouse pointer. That means we need to lock the x coordinate and only allow the y coordinate to change. Does that make sense? So I want it to only move up and down. Keep your x coordinate of -203, please. Only allow the y coordinate to change based on the mouse pointer's y coordinate. Okay? That is the goal. So, let's see here. Is there a mouse X or mouse Y somewhere point towards? I know it's somewhere. Let me find it. There it is. Mouse Y. That's what we would like. If you set Y to be the mouse pointer's Y coordinate, then that only ever changes the Y coordinate based on the mouse's Y coordinate. Okay? And the X stays whatever it was starting with. Does that make sense? And so now my mouse can be way over here, but it's only using the Y coordinate of the mouse to affect the paddle. Okay? The X coordinate is never changing. Isn't that cool? So forever set Y to mouse Y. And mouse Y was down in sensing. That's the variable that's always set to the mouse's Y coordinate. Okay? Any questions about that so far? That's kind of nice. Just move the mouse to move the paddle. Alright. The next thing that we have to hook up is the ball. Right? The ball needs to bounce around. So, I think we should start the ball maybe in the middle or something. Maybe at a random spot, actually. Let's start the ball in a random place. Or you know what? Maybe you can start in the same place, but it should have a random direction always. Something like that. So maybe we'll start the ball right here always, wherever that is, -44 and 30. So let's make sure that the ball always starts there. So at the beginning of the program, always ball, please go there, to that middle point. And then I would like you to point in a random direction so that it's ready to move somewhere weird, right? It should be a different game each time. So we know how to make it point in a random direction based on our star program. Let's do that. So point in direction, some random direction between, now it really is correct to do 0 and 360, right? We want all those options. Okay. That would make the most sense. Let's see. Is that good enough? Do we want the ball to be able to go that way always? Let's make it more interesting, maybe. Let's only allow the ball to start off shooting in this direction to give us some time to set up and not have like a bad game. So maybe we'll only allow the direction to start out in like up here, maybe like 40 degrees, all the way to, you can start moving like 140. Those are opposites, right? 40 and 140. That seems like a good range. So this was my idea. Maybe only allow the ball to go and start off at most up here, 40 degrees, randomly between all these options down to 140 degrees based on its coordinates. All right, so that's the starting direction of the ball. That's what I would like. So maybe we'll make it 40 and 140. Okay, and then it has a random direction at that point, but it's not moving yet, right? The ball needs to always move. So how do we do that? Again, star program. So forever, ball, please move in your current direction. So forever, motion, move 10 steps, and it's implicit that it's moving in its current direction, right? And so if I run this, it's different each time. The ball bounces off that way, ball bounces off that way randomly, ball bounces off that way randomly, rerun, rerun, rerun. And so it's only bouncing off in that range of degrees. But right now it's not bouncing off the wall. We got to do that too. So that's the if on edge bounce, right? That whole block. So move a little bit, if on edge bounce. Move a little bit, if on edge bounce. Okay? And that's the balls program. The paddle is only hooked up to the mouse, and that's all it needs. The ball has a bit more fancy things to do. It needs to start in the middle, that random coordinate right there, negative 44 and 30. Then pick a random direction, and then forever move in your random direction. Whee! Bouncing off if necessary. Look at it go. So that's mostly Pong, right? We still need to hook up. We need to hook up the paddle with the ball, right? That is very important. So let me show you how to do that. That has to do with the sensing part here. It has to do with touching, right? We know that we're hitting the ball if the paddle is touching the ball. Yeah, that's the goal. So we want to check that too. If on edge bounce, but also if you're touching the mouse, or not the mouse pointer, if you're touching the paddle, please bounce off then as well. Okay, something like that. So we're going to need another if inside of all that. And we'll work on that in just a second. Okay? Let's talk about, though, bouncing, because that is important. Whee. The ball's coming down, maybe, eventually, coming like this way, this direction. And then the goal is the ball needs to bounce off the paddle, right? I'm going to teach you an easy way to do it right now, and then we're going to figure out the proper way in a future lecture. But like, here's the ball. It's going this way. We would usually like it to bounce off this way. I'll show you how to do that in a future lecture, I promise. But right now, let's just bounce it off exactly the way that it came, because that's easier to think about right now, okay? So if the ball is coming in and it hits the paddle, we would like it to bounce off in that same direction, or in the opposite direction. So how many degrees is this? How many degrees is turning around? That's just 180, yeah. Good. So I would like the ball to do a 180 whenever it hits the paddle. Whenever it touches the paddle, move in the opposite direction. Okay? Flip. Okay? And then it'll start moving off in this direction. And the rest of all this move 10 step stuff should take care of it working. Okay? So I could do this in a few different ways. I think it's cleaner to do one way versus another, though. What I could do is I can put an if in here, and I have a feeling that might make you feel a bit uneasy. So there's a lot of stuff going on in that forever loop. So alternatively, we could do it like this. We could make a separate program that also runs when the ball begins its life. Two programs running at the same time. Why not? And then we just keep track of that same checking. Okay? forever, keep on checking if we're ever touching the paddle. If so, bounce off. Okay? I'll try my best to keep these in a spot where we can see them both. So, 2 different programs running when the ball begins. One is worrying about setting up the ball and having it move in its direction. And the other is only concerned about, let's just have this program. This program will make the ball bounce off the paddle. That's its only job. The ball bounce off the paddle. That's all we care for it to do. I think it's easier to think about that way. Okay? All that this cares about is noticing if we touch the paddle. If so, bounce off. Okay? And what does bouncing off mean? It means for the ball, you better change your direction to be whatever it used to be plus 180. Yeah? And that's how that's going to work. So if the ball, this is the ball's program right now again, if we're ever touching the paddle, like if we're way over here, like here and here, boop, and we bounce off, we want to bounce off, like we're coming in this way, we want to bounce off that same direction, but opposite, so plus 180, okay? So that is change your direction most likely. I guess you can just say turn. That also works. Turn 180 degrees to the right or the left. Doesn't matter because it's 180. Okay? So that should do it. So if this program moves the ball and sets it up, and this program just worries about flipping it if it ever hits the paddle. Okay? Something like that. So here we go. Of course, it still works normally. It bounces off the walls. That's this first program. But it should also bounce off the paddle now. Whee, there it goes. If it ever touches it, we reverse its direction, and that's going to let this other program that's worrying about moving the ball just move it in its current direction, but its direction just got changed. Okay? That's the goal. That's the idea. Any questions about how these 2 programs are working together? Technically, I didn't even need the second one. I could put this whole if thing inside of here. It would also work, but it's kind of like a separation of concerns, I would say. Move the ball program, hit the paddle program. Are we good to continue? Does this make enough sense? All right, because we have a few more things that we can worry about. We can give points, right? We could keep track of like how many times we did something nicely. Like we can make a points variable, something like that. At the beginning of the game, set points to 0. Change points by 1 every time we hit the paddle. So right here, right? That's not too bad. Just always show points. So start at 0. Increment it if we ever hit the paddle. That's what this whole big if block is checking, right? So in addition to move around, do a 180, also increment points. So now we have 1 point. Now we have 2 points. 3 points, yay. Are we still good? So this is super fun, and I encourage you to play around with this, definitely. But the one last thing that I think I want to do, the one last big thing, we'll do you lose in a second, is we need the game to end, right? We need the ability to lose the game if we mess up. If the ball ever hits the wall, it should have stopped. The game should have ended. Yeah? So there's a few ways of doing that, checking if we hit the wall. You could check if the x-coordinate of the ball ever got super small. That's one way to do it. Another way that might be easier is just make a really long line that will be, here's a long line, that will just be the out of bounds section. And we can just check if we ever touch this line, put it right here. And now if the ball ever touches that line, then the game's over, right? That's an easier way to do it, I think. So back to the balls program. We can make this part of the lines program. Who cares? When the line begins its life, it just needs to keep checking, hey, has the ball hit me? If so, the game is over. Okay, so let's do that. So the ball is moving. So I have a paddle program moving based on the mouse. I have a ball program, 2 of them. One about moving it and setting the points to 0. One about seeing if we hit the paddle. And then let's just have the line keep track of whether or not the ball hits it. Okay, that works. So again, forever, keep checking if the ball hits me. So if I am touching the ball, oops. If I'm touching the ball, then the game should be over, right? And one way to make the game be over is to use a stop block. That stops the program. That's the equivalent of clicking the stop sign. Okay? So if the line, this is the lines program, if the line is ever touching the ball, then the game should be over. Let's stop the game. Stop the entire program. Where is that? Is that, I would assume it's in control. Yeah, stop. Stop all. Stop everything. Every program everywhere. And notice how, isn't this cool? Notice how you can't put anything below the stop block. See how it doesn't have a little indent? It kind of implies, it makes it very clear that that's the end of the program. Nothing can come after it. Isn't that nice? So let's see if it works. So I can get points. It still works. And then if this ever happens, the game stops and the ball stops here. Now the paddle's not following my mouse. That's the end of the game. Okay? That's essentially it. The last thing we can do is have like a custom you lose sprite that we can make appear, and I think that's again going to be part of a future assignment, so I'm going to show you how to do that now. You can make a new sprite, right? Here's the painting a new sprite bit. I don't know. How do we want to do this? Fill it in with, can I fill the whole thing in with purple? I would like to. Oh, we at least need this. You lose. Sad day. We can make that huge, most likely. I'm dragging that. Can I make like a little backdrop anywhere? Send backward. Make it, I don't know, transparent. You can have so much fun with this. These are just gradients. I think, whatever. You don't have to do too much with this, but it works, kind of. Whee. Now I can't click the text anymore, so let's just make it say you lose, who cares? And that can be our, oh sorry, that was a costume. My bad, it was supposed to be a backdrop. I just made a sprite called you lose, excuse me. I guess it'll work. Yeah, that's fine. That can be a sprite. Could also be a backdrop. So we're gonna have this you lose sprite start out hidden, of course. Whenever the game begins, we need to hide it. So when the green flag gets clicked, that you lose sprite better hide itself. And then if we ever lost the game, we should have it show itself. And you know what we could do to have it show itself? We could have a message for that. We could have a game over message. Broadcast game over. And when this receives game over, then it can show itself. You know what else? Maybe we could have the stop block as part of the you lose game. Let's do that. Then I don't need this. I can just say broadcast game over. So if the ball ever touches the line, broadcast game over, and then it's going to be the you lose sprite's job to receive that message, show itself, and then stop the game. That might be easier to think about. Okay, so there's a lot of things working together right now, and I want you to look at this code, study it, because I'm going to give it to you. But are there any immediate questions about any of this? Let me just show it to you one last time. It should work, the game. There it goes. I can play. I can hit it off the wall. It'll bounce, and I can lose, which will broadcast the game over message, stop the program, and show that you lose Sprite. Okay? I guess the bulk of the work is mostly the ball, right? So definitely study that. But it's a lot of check if we're touching things. Check if we're touching things and do something. Okay? Any questions about this? I remember to save it before I forget. We all doing okay? Think you could make this yourself? All right. So, I think that is what I wanted to show you today. That's all I have for you today. Let me introduce now your next programming assignment. Release. So remember to record yourself now, upload that video as usual. What you're going to do is I would like you to make the Space Invaders game. And a nice man on YouTube has made a tutorial for it. So please watch this YouTube tutorial and implement Space Invaders. It doesn't have to be exactly what this guy is doing. You can change the sprites to be different, but all the functionality should be the same. So here's like the end where you have a game that's working. Does he show you it running? Come on. But apparently there's going to be like the Space Invaders are tacos and you have missiles and you're shooting at tacos. You can do whatever you want though. I would love to see like a... Come on. I wish I knew where there was a spot where he played it, but I don't. So just watch it and make the Space Invaders game. You can change it as much as you want as long as all the features that are talked about in the video are there. And yeah, as usual, to turn in, please upload a video of your program running. Show me the code, record it however you're used to recording it by now, and just tell me how it's working to make sure you understand it and prove to me that you understand it. You don't have to talk for very long. It's fine. Just long enough, right? So yeah, that's your program if you have programmed before, if you have not programmed before. And if you have taken like 40 or something, then here is your assignment. So please read 1.7 to 2.1 of how to design programs and do exercises 9 and 11. Okay? So that is your next programming assignment. Any questions about it? All right. So that is all I have for you for the day. So please take the rest of the time to work on whatever needs to be worked on, and I will be here as usual to answer questions.